We are so grateful for all Megan Price's involvement in WIDS. Megan gave an excellent talk in 2017 at WIDS, and even though she was 7 months pregnant at the time, she came through with great energy on stage, sharing an outstanding overview of the data science work at the Human Rights Data Analysis Group, or HRDAG. You can also check out Megan's workshop this year at WIDS. Megan and her team continue to use strong data science skills, analyzing many very tough societal and global issues, such as war casualties, identifying missing graves in Mexico, and analyzing police practices in major US cities. We also involved a shorter talk by Megan in the WIDS educational outreach to teenage students.
One bit of housekeeping for those who are particularly observant out in the audience. I'm very pregnant. And I'm also just getting over a head cold, and that combination of things sometimes means when I speak publicly, I get a little out of breath. Nobody panic. It doesn't mean I'm going into labor. It's just a reminder that sometimes I have to slow down a little bit. So, with that out of the way, let's get started. This morning, I'm going to tell you a little bit about my organization, who we are and what we do. I'm going to tell you about the two primary analytical methods that we use to do our work. I'll give you just a couple of examples of code snippets to let you get a sense of what our day-to-day work is like, and then I'll wrap things up. So I'm the executive director of an organization called the Human Rights Data Analysis Group, or HRDAG. We're a nonprofit. We're based in San Francisco. And we're essentially the behind-the-scenes scientists for human rights advocacy organizations. And my co-founder, Dr. Patrick Ball, has been doing this work for 25 years. And over those 2.5 decades, our team collectively has been really fortunate to partner with a wide variety of human rights advocacy organizations. Some of those are big international groups you may have heard of: Human Rights Watch, Amnesty International. We've worked with a variety of branches of the United Nations. We occasionally work with truth commissions, and we sometimes work with local, grassroots, non-governmental organizations. Now, the shape of our work, the outcome of our work, really varies on the specific project and the specific setting. Sometimes we write memos, sometimes we're a footnote, sometimes we're a technical appendix. But I think one of the most visible ways that our analytical work comes into play is when we're asked to provide expert witness testimony in court cases. As Patrick Ball was in 2002 at the International Criminal Tribunal for the former Yugoslavia, when he was asked to testify against Slobodan Milosevic. And here he's presenting patterns of refugee flow across the border into Albania and patterns of known killings during that conflict. He also testified in Guatemala in 2013 against General Efrain Rios Montt, the former de facto leader of Guatemala in the 80s. And here he's presenting a comparison of the relative risk of death for members of the indigenous population as compared to members of the non-indigenous population. And this comparison allowed lawyers to make an argument that the patterns of violence were consistent with what you would expect to see with targeted killing aimed at a specific ethnicity. So patterns of violence that would be consistent with acts of genocide. Rios Montt was found guilty of acts of genocide. Unfortunately, that verdict only stood for 10 days. The Guatemalan Constitutional Court overturned that verdict on a legal technicality. And this case is continuing to wind its way through Guatemalan courts. Excuse me. Most recently in 2015, Patrick testified again, this time in Senegal, against the former leader of Chad, Hissène Habré. Here he's presenting the crude mortality rate that occurred in secret prisons run by Hissène Habré, run by the secret police, managed by Hissène Habré. And this trial has the most positive outcome of our stories so far. In 2015, Patrick testified. In 2016, the judges came back with a guilty verdict, sentenced Hissène Habré to life in jail. So far, that verdict has stood. So what are we actually doing when we're presenting these results in court? Well, for most of our projects, we rely on two specific analytical methods. And the first one is this big class of methods called record linkage, or in various other applications, database deduplication, entity resolution. Fortunately for us, this problem arises in a wide variety of fields and applications. And so this is an incomplete list of the references that we rely on in our evolving thinking about this problem. Given this conference, I mostly want to highlight the last bullet point that we rely very heavily on specific modules in Python to carry out much of this work. And that's the specific example I'm going to touch on in a minute. But I do want to mention the second analytical method we use, which we refer to as multiple systems estimation. Now, for the statisticians in the audience, you'll know that MSE usually means something totally different. But we prefer to call this multiple systems estimation. It was developed 150 years ago in ecology for studying the size of animal populations. And there it's called capture-recapture. But as a human rights researcher, I try to avoid talking about capturing humans. So I prefer to call this method MSE. It's a very broad class of methods. Again, this is an incomplete list of references that we rely on. And to highlight that last bullet point, right now we primarily implement this work in R using two specific packages that fortunately for us were written by friends and colleagues. The DGA package was written by Christian Lum, James Jandro, and Patrick Ball. And LCMCR was written by Daniel Manrique Vallier. And both of those implement MSE models using a Bayesian, a Bayesian approach. So I'm not going to have time to talk much about MSE today, but during the Q&A or offline afterwards, I'd be happy to get into that. To get into our specific example this morning, this project started in 2012 when the United Nations Office of the High Commissioner for Human Rights came to us and said, we have these 4 different sources that are recording information about people who've been killed in Syria. And that's a little unusual for us. Usually we have one trusted partner on the ground who provides us with information. We're not really sure how to make sense of this particular data landscape. And so they asked us to help them analyze and describe these 4 different data sets. So for a couple of years, we co-authored a variety of publications. This one is somewhat out of date, but this is the last official publication that we wrote with the UN. But it's important to note in this headline that it's missing 2 important modifiers. This number describes the number of documented, identifiable individuals who've been killed in the ongoing conflict in Syria. And if you think about violence and conflict violence, it should rapidly become obvious that that's a subset of all victims, because not every victim is identified. Not every victim's story is told right away. It may be days or weeks or months or years before we hear certain stories from the conflict. So inevitably, this is a subset of those total number of victims. And I'm going to come back to that at the end, so I just want you to sort of think about what that means for our data and our analysis. But for now, we'll start with what we do know, which is based currently on 4 sources: the Center for Statistics and Research Syria, the Damascus Center for Human Rights Studies, the Syrian Network for Human Rights, and the Violations Documentation Center. And each of these groups collect lists of named victims. And from the beginning of the conflict through the end of 2015, they've collected over 400,000 records of named victims. Now, I need to be very clear here. That in no way implies that that is the number of victims. There is a lot of duplication in that collection of records, because many victims are reported multiple times to the same source, perhaps from different community members, or they're reported multiple times to different sources. Perhaps their family member reports them to all of the sources that they have access to. So the first thing we have to do is deduplicate those records. And what do those records look like? This is a screen grab from the public-facing website of the Violations Documentation Center. This is part of their advocacy work. They think, and we agree, that it's important to raise awareness about these victims, to tell their stories, to say their names. And most of the lists look similar to this. They are the names of the victims, the date and location where they died, and any other demographic information they've been able to collect. And that's where we get to this record linkage problem, which HRDAG sort of organizes in this very full diagram. And I mostly just show this to say there are a lot of steps involved. I'm going to tell you about 2 of them today. But what we do is supervised record linkage. So all the symbols on the outside, everything that starts with a TS for training set, is data that goes out for human review. And everything down the middle is what we automate and code and rely on computers to help us do. If you want to get into some of the more technical details, we've been building out the tech corner on our website. Last year, Patrick wrote a geeky deep dive on some of our blocking techniques. Last summer, he also wrote about clustering and solving the right problem. I really enjoy this one because he describes, as I'm sure all of us have experienced, really enthusiastically solving the wrong problem multiple times before you find the right one. But again, I'm just going to focus today very briefly on compare and classify, kind of in the middle of this diagram. So if we think about pairs of records, and we just want to ask ourselves, does this pair of records refer to the same person or not? And if I have any Arabic speakers in the audience or watching the live stream, I apologize. When I mix Arabic and English, one of them has to end up backwards. So all the Arabic on these slides is backwards. But there's 2 ways we can think about this comparison. We can ask a human, do you think these 2 records are the same person? Yes or no. That's how we create training data. And we can also numerically summarize how similar or dissimilar those records are and feed that into a computer model. And we can do all kinds of string metrics and comparisons and look at tokens, and we can look at how many days apart the dates of death are and how different geographically the locations are. And those are the 2 key pieces of information that we feed into a classification model. We give them the human-labeled training data, and we give them the features, the numerical summaries of the similarities and the differences between those records. And fortunately for us, sklearn has baked in basically any classification model you might want to consider, and a variety of diagnostic tools. So just as an example, we might look at random forests, decision trees, and logistic regression. And again, feed them that human-labeled training data and those feature vectors, that numerical comparison of the pairs of records. And then we're going to get back a score. We call it a probability. We're playing fast and loose with our terminology. But essentially, we're going to get back a number that we can set a threshold on and say, above that, I'm going to call this the same person. Below that, I'm going to say these are not the same person. And so that gets us to classification. Now, eventually, we're going to have to work our way through the rest of this diagram. We're going to have to decide if record A and record B are the same person, and record B and record C are the same person. Are record A and C? And we're going to have to form some clusters. We're going to have to break up some clusters. We're going to have to do some more post-processing and human review. But eventually, we're going to get to the end of this record linkage problem. And what we're going to have at the end of that problem is a database that tells us the number of uniquely identifiable victims who've been documented by one or more of the sources that we have access to. Now, that's not the same as the question that I started this talk with, because I have slightly misled you. We're only about halfway through this problem, because what we have done now is we've identified that subset of identifiable victims. And our job as data scientists is to recognize that there's some amount of the population that we don't know about yet. And we need to use the rest of the tools in our toolbox. In our particular case, that means MSE, but we have other options, to estimate what we don't know. And so that's really the next step. If we want to be able to answer this substantive question, we have to do more than just look at what we've been able to document and record. Unfortunately, that's a whole nother talk that I don't have time to give you this morning. So I will go ahead and stop there and say thank you, and I'm happy to take questions.
Thank you so much, Megan. Terrific. Okay, I'm sure there are lots of questions. Can we have a mic here? And maybe in the meantime, another mic is already ready? No? No, you're fastest.
Hi, Megan. Great talk. I have a big picture question, not just to you, but for the tech leaders here. I'm a postdoctoral researcher working on climate and energy data.
Great.
So, as you know, we are under immense pressure under new administration. EPA is at risk, and we have been recently notified that whatever research we do is going to go under quote-unquote political review. So I want to know if tech leaders will be willing to step up to fill this gap, because this is going to be the next big humanitarian crisis, and we have been muzzled. And so it's not just from the business point of view, but from the independent research point of view, if they can step up and fill this gap.
I could not agree more. It's easy for me to say, since I work in the nonprofit space, to say we occupy that space now, we're going to keep occupying it. I hope that other tech leaders will step into it as well. One of the things that we all reflected on our team after the election was that for the last 25 years, we have held state leaders accountable for violations of human rights, and we will continue to do that at home and abroad.
Thanks so much for your talk. My question gets at something that you were talking about at the very end. So we know, of course, that many of the people that die in wars like Syria are not killed directly, right? They're victims of disease and indirect consequences of conflict. So are you guys trying also, as you're estimating the number of people who've died, to get at those kinds of effects, or are you just trying to get at the number of people who you think have been killed in actual violent events?
That's a great question. Our particular project and our particular analysis focuses on what we refer to as conflict deaths. So those are directly related to the violence. And the MSc methods that estimate what we're missing, like any other inferential method, are based on what we are able to observe. And the lists are conflict deaths. But if we did want to get at indirect deaths, then we might use more conventional public health approaches like a retrospective mortality survey or a household survey, or other demographic techniques to look at what we would expect the population distribution to be, to try and get at some of those questions. We're not looking at that right now in Syria. We have historically taken that approach in some of the other conflicts we've worked in.
We have a Twitter question.
From Twitter, we have, how do we incentivize data science for social good when it's often not coming with a direct monetary benefit?
That is such a great question that I have been pushing on other people in my field really hard, and I wish I had a better answer, because I meet young folks all the time who want to go into this field, and I want to encourage them, but it is a hard reality that there are not a lot of jobs in this field. And I don't have a very good answer for how we can grow the support for the infrastructure that is going to be required to create more organizations like mine, more centers, more places that can then hire folks to do this kind of work. Unfortunately, I don't have a good solution to that.
It would be great actually if the big companies would dedicate a certain percentage of their research capability to those questions.
I would love that.
Wouldn't it be great? I'm just putting a bug in people's ears here. Think about that. We need it more than ever. We have time for one more question from the audience.
Hi, so kind of on that note, for those of us who are still students who might be interested in doing kind of data science for public good, what recommendations do you have for either skills or experiences or things for us to go after?
Sure. In terms of skills and experiences, I mean, I think mostly it's a lot like the last answer to that question. Is just being really creative in your problem solving and being really open-minded, because our data always break all of our toys. And so you have to kind of be willing and comfortable to think about weird corner cases and build your methodology out to suit your needs. In terms of resources, we could talk a little bit more offline, but the main two that I usually recommend to students, unfortunately they're not money-making, but they're a good way to kind of get a sense of the landscape, is within the American Statistical Association, there's a group called Statisticians Without Borders. And they're all volunteer, and anybody can sign up for their newsletter, and so you can get a sense of the work that's being done. And then also DataKind, which again is a volunteer organization. It has chapters in a variety of locations, including here in the Bay Area. And again, it can be a way to get a sense of the problems that are out there and the questions that are being asked.
Fantastic. Thank you so much, Megan, for your work, for your talk, for everything.
Thank you.
Yeah.